Hello and welcome to all new episode of Artificial Intelligence. In this video we'll talk about AI created by NVIDIA researchers that creates human faces who does not exist. So, let's get started. Generative Adversarial Networks, GAN, are a somewhat new theory in machine learning, proposed for the first time in 2014. Their purpose is to synthesize artificial examples, such as pictures that are obscure from authentic photographs. A typical example of a GAN application is to produce artificial face pictures by learning from a data set of notable faces. StyleGAN is a generative adversarial network introduced by NVIDIA researchers in December 2018, and made source available in February 2019. StyleGAN depends on NVIDIA's CUDA software, GPUs and Google's TensorFlow. The second version of StyleGAN, called StyleGAN 2, was published on February 5, 2020. It removes some of the characteristic artifacts and improves the image quality. On October 12, 2021, NVIDIA released StyleGAN 3, described as an alias-free version. This model is proficient in producing impressively photorealistic high-quality photos of faces and grants control over the characteristic of the created image at different specification levels by changing the style vectors and noise. The StyleGAN neural network architecture has long been considered the cutting edge in terms of artificial image generation, in particular, for generating photorealistic images of faces. StyleGAN 3, removing a major flaw of current generative models and opening up new possibilities for their use in video and animation. The first two videos demonstrate the texture sticking issue in two cinemagraphs created using generators trained on the unaligned FFHQ dataset. The looping videos show small random walks around a central point in the latent space. Observe how the details, hairs, wrinkles, etc. The StyleGAN 2 result appear to be glued to the screen coordinates while the face moves under it, while all details transform coherently in our result. Observe again how the textural detail appears fixed in the StyleGAN 2 result, but transforms smoothly with the rest of the scene in the alias-free StyleGAN 3. We note, in particular, how StyleGAN 3 appears to have learned to mimic camera motion in the beaches dataset. For those who have spent much time looking at video generated using previous version of StyleGAN, one of the most unnatural visual flaws was the way that texture like hair or wrinkles would appear stuck to the screen, and not move naturally with the rest of the object. See this video comparing StyleGAN 2 and StyleGAN 3, notice how beards and hair in particular seem to be stuck to the screen rather than the face. Although StyleGAN 3T is equivariant to translations, the output is severely corrupted under rotations. StyleGAN 3R however is equivariant to both translation and rotation. Here's the research paper, you can find the link in description.